Hi, this question is remove invalid parentheses. So you're given a string S and then it contains parentheses and letters. So you want to remove the minimum number of invalid parentheses to make the input string valid. And then you want to return the unique string that are valid with the minimum number of removal. So this question you can go with DFS or BFS. So let's talk about the DFS first. So we are given the string S, and then we are able to count the number of open parentheses and closing parentheses. So we definitely need to know the invalid parentheses. That means you have one opening and two closing, or one closing first then opening second. So this doesn't count as valid. So the parentheses mean that you need to have like open and close by order, or open and open, close and close. So you want to make sure this will become valid and this will become another one valid. Yeah, so what we should do is we want to make sure how many valid open parentheses and how many valid closing parentheses. So what that means is you can actually just keep on track of opening. If the opening you have to see the opening first before you see the closing, right? So opening will go first, and then if you see like closing, and then we just want to make sure is if opening count is greater than 0, then we decrement the opening. Other side we are just increment the closing. So that being said, like we want probably this scenario. So you have closing first and opening second. Like this won't become the valid scenario, right? So later on you will return the empty list, right? So what you should do is so let me remove this. So what we can do is, once we know how many opening and how many closing, all right, just imagine we know this, then we want to make sure we're using the DFS to recursively traverse whether or not do we want to use this character or not using a character. So it goes to where every single index. So I would say take it or not take it, not take it, and then this one will follow the same, take it or not take it, not take it, and so on. And then once we so we know opening and we know closing, and then when we take it, we want to increment the opening, but not with this. Like this is the global variable that we are tracking, and then when we are trying to build in the string builder, like for this, we are trying to count how many closing and how many opening and how many closing in the string. So this is a global opening and closing that we are not trying to modify, but when we are trying to build for the output, we want to make sure we have a counter to keep on track of opening and closing. So basically we can just using one variable. Just imagine you say open, right? So if you see opening, then you open plus plus. If you see closing parenthesis, you open a minus minus, and then yeah. So this will be it. So the moment you see this, so imagine this. This is plus by 1, plus by 1. Plus by 1 right here, minus by 1, minus by 1, and this is 0, right? And then you have another plus by 1, minus by 1, and then this becomes 0. And which is going to be considered this is true, right? So you have two of this that map with this, and then you have another pair map with this. So at this moment we know that everything becomes 0. The count for this becomes 0, and global and closing becomes 0 as well, because we are trying to use it, but when we use it, we want to make sure we are incrementing the counter. And then when we are not using, then we are just remain the same count. So anyway, so let's do it. So we are going to have a hash set to represent scene. So you might traverse the same string over and over again. So so if s equal to null or s.length is equal to 0, you can return empty. And I like this to be after the base case. And then when we want to start and we want to make sure this is going to be like this. Open parenthesis count by default, and then closing parenthesis count, and then I can traverse so if c equal to opening and c equal to closing. So we want to make sure we are trying to clearly define the character, because you can have an alphabet later, right? So that being said, you are trying to increment right here, and then when you see a closing, we want to make sure if the opening parenthesis count is greater than 0, then we are just subtract. So we are just equal out, you know. So we are trying to make sure that this will be appear for opening and closing, and then later on, if opening parenthesis is actually becomes 0 or less than 0, we are just increment the closing parenthesis. Okay, so once we know, like, because we want to make sure like what is the global closing and what is the opening, right? And then once we are trying to build a string builder for every single, you know, output, we need a string builder. And then you can just return, you can just call DFS. You need to pass in the string, the original string. You need to pass in the index that will keep on track of the original string, and then you will pass in the string builder, and then you are pass the global opening and closing. And then by default, you are starting for the 0. This will represent the number of the count that you are trying to traverse for the string from here to the string builder. Okay, so you are later return to. So I'm just convert the hash set to array list, and then so you can have a string s, and then this will be index, this will be string builder, this will be open parenthesis, closing parenthesis, and this is going to become open. Technically it's just a counter. Okay, so like when we are trying to traverse this, I just imagine the first one. We know this is going to be equal out, so opening still remains 0, closing remains 0, and then opening still remains 0, closing remains 0. So this will be, closing will be by 1, and this will be opening, you know, opening will increment. So let me just draw really quick. So this is opening, this is closing. So you are starting from the index 0. So opening will come by 1, and then if you see closing, then you're just decrement here to 0, and this will be by 1 again, and then back to 0 for next index, right? For next index, we'll back to 0, and then another closing right here. So this become -1. So you are not trying to modify this. You are trying to update the closing. Then later on you see this, so you come back to 1. Then this is closing, and then I see the count for the opening is greater than 0. Then I, you know, reset back to 0. So at the end of the day, you are passing 0, 1, 0 into here. And that being said, you are trying to make sure when you are trying to, so that being said, you need to remove, one closing in this string s, then you will have the valid string, right? So you are going to use this, use every single opening, right? And then every single closing beside one, like really, like you just need to get rid of one closing. So this is the idea, and then I can make sure that if the opening is less than 0 or closing less than 0 or so this open represent a count for string builder when you're trying to add. So that being said, you just don't care about recursion. So this is going to be a base case. And then if the index is equal to the s.length, so which is going to be a last character, then you want to make sure if the opening parenthesis, closing parenthesis, and this open for the count for string builder is equal to 0. If this is true, then you just add whatever the string builder to the set. And then if they are not equal to true, then you just return. If they are also equal to true, you still need to return because you are reaching to the last index. Alright, so what we can do is we need to know, so we are trying to add a character into string builder, and you are using DFS, so which means you want to reset the chart back to original. So what you should do is you want to find out, so first of all, find out the current character, and then you want to find out the original string, and you want to, so for the string builder to reset is pretty straightforward. You just say set string builder dot set length to original length. Let me just call this, and then this, you have 3 different scenarios. So when the C is equal to opening, when C is equal to closing, and this is going to be the scenario for the later. So when you are trying to recursively call for the later, technically you are just ignoring, right? But when you say ignoring, you still need to append whatever the current character into the string builder, right? So you increment the count, but you add the character into the string builder. However, you are not touching the opening, you are not touching the closing, and you are not touching the count for the open. So this will be like a pretty standard scenario. And then for this scenario, you are going to say take it, not take it, and this will be exactly the same thing. Take it, not take it. So if we want to take it, so you still need to increment your index. So if you are taking this, right, then you are minus the open parenthesis, untouch the close, and then open remain the same. The reason why is this is because you want to, so for this scenario you want to take away, like when you take it, like you want to take away this opening. So imagine you have extra opening parenthesis, so you take it, you take away, like this is what I mean. And then if you don't not taking this, then you are using the opening for this string builder. So, and then that being said, you are append the current character, so you are not touching anything, and then you increment the count for the string builder opening parenthesis, and then this will be exactly the same thing. So you are trying to take away the extra closing parenthesis, right? And when you not take it, then this will be -1. So the reason why this is -1 is because you are adding the opening parenthesis into a string builder, and then if you see the closing one, you are definitely dealing with the the extra one for the string builder, right? And then you definitely need to have dot append the string builder. So this should be the whole entire solution. Okay. So okay, so I believe there is a scenario index +1. Okay, so this is a common mistake. When I say original string length, it has to be a string builder, not the string s, because the string s will keep the string remain the same every single time. But what we are trying to do is we are trying to append a character for the string builder and reset the string back to whatever the original one for the string builder. So I just add this, I literally it was s.length, right? So it's just sp.length. Okay, so well, this is going to be DFA solution. Time and space is pretty challenged, so you are trying to take two different direction. So it's going to be 2 to the n for every single iteration. So the worst case is 2 to the n, and I mean this is all of n, doesn't matter, but the problem is right here. So it's going to be 2 to the n for the time, and for the space I would probably say all of n. So so now we know the DFS. So let's talk about the solution for BFS. So breadth-first search will be a little bit tricky. So what we are doing is we are trying to just pass this string into the queue, and then when we are trying to see the opening or closing, we want to make sure like is the current character a mouse or not, right? If this is like if you're passing the queue, so you are passing the queue. My bad. So you're passing the string into the queue, and this is represent the highest level. So think about this: you want to return the minimum number of minimum number of removal, right? So this will be like level 1, and then level 1, and then if you have another possibility to create another string, this is going to be level 2, right? So I'm going to say S1, S2, S3, something like this, and then this will later on will be possible to level 3 and then level 4, right? So whenever you find a string that is valid, that is considered the minimum number of removal, because the more level you go is considered like the more removal you are going to use. So that's pretty clear. And then what we are trying to see is we are trying to push the original string into the queue, and then we are trying to compare we're trying to validate the current string is valid or not. If this is not valid, then we are trying to substring every single, we are trying to build out the possible every single string from the original string when you are just pulling from the queue. So imagine that you have this in the beginning. I'm going to have like every single possibility to create a substring into the queue. So I'm imagining this. I'm not dealing with this, so I'm going to say, okay, this might be the solution. So I'm pushing this to queue, and so I just remove the first one, and then I'm going to remove the second one. So the second one will become this, right? And then so on. I'm going to just, you know, find all of the combination for the current queue, the current string that pull from the queue into the queue back. So that will consider the next iteration, right? So yeah, this might be hard to explain, but I'm just trying to you know, give you a little bit background. So I'm going to using the array deck for the queue, and definitely you need to find out the, you know, the same string over and over again. So I'm using the hash set to avoid the conflict, and also I'm returning the string for the result. Okay, so what I need to do is I just basically, actually I need a base case. Alright, so now I just push in the queue. So at last, so pushing the string into the queue, and then I'm going to just say is queue is not empty. I traverse. So this size will become the iteration level. So the earlier you found out the result is not empty, then you are breaking it. So think about this. So I will traverse based on the size, and then for the string I'll say just a no queued up poll, and then for this iteration they will consider like the current level. So if the current string is valid, then I just add the no into the results. So I'm going to say boolean is valid string s. So how do we know it's valid? We just literally just check the open parenthesis. So if c equal to open, I'm just say open plus plus, else if c equal to closing, then open minus. And whenever there's a scenario when open is less than 0, then I'm going to return false because it is not a valid string. Also, I'm going to return true. But the problem is you can have extra parenthesis, right? The open parenthesis, right? So I'm just trying to make sure the open equal to 0. This is like more secure, and it should be a valid scenario. And then so if this is found, which means this level will be the current level that you need to break. So you don't need to go on another iteration. So that being said, if result is not empty, then you can break, then you will return result. So what happened if this is not valid? Then we want to make sure first of all the result is currently empty. So if this is not valid, then also this is not empty, then we already know that whatever the string from the queue, that doesn't consider a valid string, but there will be another string that is in the current level that is valid, that you don't need to care about it, right? So what happens if this is not valid and also this is true, right? Then we want to generate another combination, right? We want to generate all combination based on this node. So I will using this. So j equals to 0, j less than node.length, and then j plus plus. So I'm trying to get all of the combination from this node, okay? Only if the current character is opening or current character is closing. So what I meant is I know that this is not valid, and also there's no valid string in my result. Now and I know that there will be some character that is considered extra. I mean, it could be some or it could be only one, it doesn't matter. But I'm gonna just make sure that I'm trying to get rid of opening if I found, and then if I found out there's a closing extra, then I'm going to just regenerate. So so string that would be adjacent using the string builder from 0 to j plus substring from j plus 1. So what I meant is I'm literally ignoring j, right? So whatever character for the j position, I ignoring. So this is exclude, right? And then this is like continue from j plus 1. And then I want to make sure the scene dot adjacent is not found. Then I can just add my queue. So this is a queue, right? First in, first out, right? So I'm going to add the last into the queue, and also scene.add the adjacent, so I don't need to revisit again. So this should be the solution. Array deck. And why is this j? So this is considered empty. Alright, I made a common mistake. I shouldn't use the S. So this is a whole entire mess. So what I need to do is I want to replacing the character for the current node. So possibly. Yeah, so what I need to do is, so I'm trying to generate another possibility for the string. I need to use the current node and not the original string. So that was why I have the problem. And also when we want to use an array deck, we want to use in the remove first. So first in, first out. So this will be the whole entire solution. Yeah, this is a mistake I made. I need to consider the current string, not the original one, because you are trying to get a combination from whatever level string you are iterating. So this is why. And for the time and space, for the time, I would still consider this is going to be 2 to n. Like you are trying to generate, so first thing, so for the first level, which is original string, this is original string, right? So 2 to 0, and then this will be considered like the number of the generation. I would say 2 to 1, and then 2 to 2, 2 to 3, something like this, right? Definitely it will becomes the problem for the length of the string, but this is considered level, right? And then for every single string, I'm trying to either take it or not take it, so it has to be 2 to n, and this will becomes another 2, right? You are trying to go through the like the power of 2, right? So I would say 2n plus 1. I mean, I don't know, but it should be. And then the space, this space is considered more crazy, so I would say 2 to n as well. So this will be the whole entire solution. So yeah, I'm going to go over this solution again. So I'm going to add in the original string to the queue. I want to traverse the queue until empty. So I declare the size for my queue that represent the current iteration for the level, and then I'm traversing the whole entire level string for the current queue. Okay, so if the result is not empty, that being said, you already found the minimum number of removal. So whenever the result is not empty, that consider the minimum number of removal, right? And what you are trying to pull from the queue is whatever the combination you generate from here, or you are getting the string from here, and then you check whether or not is the current node is a valid one. If this is valid, then you are adding to the result. Also, you are checking whether or not the result is still empty. If this is still empty, then you can iterate to get whatever the next generation, next combination. for the string node when you are discard the opening and closing for the current index. And then if the result is not equal to empty, that being said something is already valid in the current level that you don't need to keep traversing. And so this will consider like the index for the current node, and then you want to make sure you want to discard the extra opening and closing, and then you generate a new string and then check whether or not is this string in the hash set. If not, then you are adding to the queue, so it has to be a last, right? First in first out, right? And then you also need to add this the string into the set, so that you don't need to traverse again for the conflict. And the is valid is pretty straightforward. You are checking whether or not the opening counting the opening and counting the closing as well, but based on the opening counter. And if the opening is less than 0, you return false, and at the end you want to check whether or not the opening is still remains 0, because it could be happen greater than 0, which is not valid. So this will be the whole entire BFS solution, and I'll see you later. Bye.